Hello, this is a video about the project assignment for Skyfi Labs online course Machine Learning using Python. In this video, we'll be seeing about the Boston housing prices and calculate the predicted values from the target values. Firstly, we have to import the NumPy and Pandas as well as the matplotlib.pyplot and the datasets from the scikit-learn. You have to load the Boston dataset and then the metrics, mean squared error, train test split, and min max scalar. Here firstly we have to load the dataset, so we will give a new variable Boston and load the Boston dataset and print the description. So over here we see the complete description of the Boston dataset, and then you have to start putting the data into the pandas data frame. Over here we take features as pd.data frame, and we'll create a column called boston.featurenames, and we'll put everything into the data frame. And nextly over here we take another column targets and put this also into the data frame and display the targets. These are our target values over here. After that we have to concatenate the features and targets into a single data frame using the concat function, and this is the logic given. So these are our target values, these are our final target values after concatenating. And nextly we need to get the correlation between the columns of the data. So firstly we have to round the decimals to 2, and then we have to calculate the correlation. Over here we took a new variable cor and we gave the function, and after that we need to calculate the absolute values of correlation. So over here we have calculated the absolute correlation attributes of the target, and we have put the list, we have displayed the features as a list. Finally you have to use the zip functions for the correlations as well as for the list of the features, and then sort the data, and you have to label the zip functions and all the functions. Finally you have to plot correlations with respect to the target values as a bar graph. Over here we see a steep between the correlation variables and the attribute variables. So this is how we plot the correlations, and then we have to choose the independent variables for linear regression. And over here we need to perform a pre-processing step, so we go for normalization and we split the data using this column split. And next we have to take min max scalar, and you have to fit the transforms, that is you have to reshape it for the x scalar as well as the y scalar for our graph. After that we perform the virtualization, again split it, and now split the data set into train and test. Generally we split our data set into two sections, that is train and remaining for the test part. Firstly, now you have to start building the model. For that you need to declare the function for the error with the following variables m, x, c and t. To declare the error function you need to give the following formula as e is equals to sum of mx plus c minus t into exponent 2, and you have to return the error. After that you need to update the learning rate, and you have to return the m and c values for every point at every point of the data set. Nextly you perform the gradient descent for init m, init c, x, t, learning rate, iterations and error threshold, and you need to perform the following function for I in the range of the iterations. You have to get the error, and if the error is less than error threshold you print the error statement, or else you have to keep appending the values m and c, and you initialize the m, c, learning rate, iterations and error threshold, and calculate the final gradient descent. Finally you have to plot the trained values, and this is the virtualization of the learning process. I am plotting the regression line upon the training dataset. The blue dots are the training data set, and this the red is our regression line. And nextly you have to plot the error values. You erase the length of the error values, and here error is the y label and x is the iterations. So this is how you plot the error values. And next you need to get the prediction values. For that you need to calculate the predictions on the test as a vectorized operation. So predicted is equals to m into x test plus c. And nextly you have to compute the mean squared error for the tested and the predicted values and get the error function. And finally you put everything into the data frame, that is x test, y test, predicted, and columns, declare the columns. Now you need to plot the predicted values against the target values. Here the predicted values are the red values and target values are the blue values. Now you scatter and plot the values and reshape to change the shape that is required by the scalar. So you need to reshape everything, and when you reshape you get an extra dimension, and to remove the extra dimension here we use this following function. And again you consider everything into a list and divide the values into separate columns, and again you round the decimals to 2 and you display p dot height. So over here we see the target values as well as the predicted values. We see the target values as 13.9, 12.9. They are almost similar, that is the almost approximate values. So that is how we have predicted prices for the Boston housing using the linear regression. And we found that the target value and predicted values are almost same. So this is how we perform Boston housing. Thank you.